the acceleration when an object is traveling in a circle at a constant speed. Basically, what I'm talking about is something that goes like this. Now, if you look at this, the acceleration is going to be in towards the center. And what I'm going to do is derive it. The formula for the acceleration is going to be v squared divided by r. So I'm going to start off by saying that I have something going around this circle in a constant speed. And if you look over here, let's say the speed is v, and this is r. So at this particular point, the speed is going to be constant. Now, if I wait a little while later, then it'll be at this point, and the speed will be the same, but the velocity will change because the direction changes. Now, if this is r and that's r, what we want to do is find the acceleration. Now, if this angle is theta, what I'm going to do now is draw a diameter by extending these lines like this and like this. Now, this angle theta is equal to this angle theta. I'm going to take this vector and move it into the center. And when I do that, it looks like this. This is v. It's perpendicular here, it's perpendicular here. I took this vector and moved it in here. I'm going to take this vector and move it down here. So this vector is v. So it's perpendicular here and perpendicular here. Now I'd like to look over here, Since this vector is perpendicular, it's perpendicular here. If this angle is theta, then this angle is alpha. Now, over here, this is a right angle, so this angle is theta. Now I'm going to create a triangle here and call this side delta S. And I'm going to create a triangle over here and call this delta G. And at this point, looking at these two triangles, we'll have the acceleration. So I'm going to take this triangle and draw it over here. And what I have is R, R, delta S. And I'm going to take this triangle and draw it over here. And here I have V, V, delta V. This is an angle theta. This is an angle theta. Now if you look at these triangles are isosceles triangles. They have two equal sides. R is equal to R, V is equal to V. Now, if they have two equal sides, that means that they have two equal angles. So if this one is gamma, this one's gamma. So theta plus 2 gamma would equal 180. Well, if this is theta, this has to be gamma, and this has to be gamma. Now, in similar triangles, the ratio of sides are equal. So over here, I could say this side is to this side, as this side is to this side. So here I have delta S is to R, as delta V is to V. And now, if I multiply both sides by V, then I would have V times delta S over R equals delta V. Now, if I have an equation and I divide one side by 5, I'd have to divide the other side by 5. In this case, it's not interesting if I divide by 5, but it is interesting if I divide by delta t. So if I divide this side by delta t, and this side by delta t, and now what I do is I let delta t go to 0. This becomes the derivative of v with respect to time, which is the acceleration. What does this become? Well, here I have delta s over delta t. Delta s has the units of meters. Delta t has the units of seconds. And in the limit, as delta t goes to 0, delta s over delta t is the velocity. So this becomes v squared over r. And the acceleration, when you go around in a circle, is v squared over r. Okay, that's the derivation of the acceleration going around in a circle. It's dependent upon knowing these angles. Thank you.